How the world's largest underwater tunnel is being built. This is the world's longest underwater road and rail tunnel, and it's currently being constructed in the Baltic Sea. But how on earth are they managing to dig an 18 kilometers trench underwater, build 89 of these massive tunnel elements, and move and submerge them with such incredible precision? This is literally the biggest construction site in Europe. And yet, most Europeans don't even know that this tunnel could soon change the way they travel across the continent. For decades, all member states of the European Union have enjoyed the benefits of having one single market. This has allowed for free movement of people and goods, as well as services and capital. But many of these EU states still lack proper transportation networks and operations between their borders, which makes movement between these countries slower than anyone would like. Take the Rhine-Alpine Corridor, one of the busiest freight routes in Europe that connects the Netherlands to Italy via Germany. On this route, cargo trains are frequently delayed because they have to wait for high-speed passenger trains to use the tracks first. This phenomenon of trains needing to wait for others to pass is commonly referred to as a bottleneck, and there are a couple of these along the Rhine-Alpine Corridor. There's also the existence of single-track rail sections. In North Germany, these sections also make it hard for trains to pass each other, meaning that they sometimes have to wait for oncoming traffic to clear before moving along. This ends up causing delays in cross-border travel from Scandinavia to Central Europe across these sections. The European Union, the Trans-European Transport Network, however, has come up with a solution to address all of these in-state and cross-border travel problems, and they're calling it the Trans-European Transport Network, or in short TEN-T. This proposed solution is basically a series of transport networks made up of railways, roads, airports, and water infrastructure spanning across the European Union. Some of the mega projects included in the TEN-T initiative are the Rail Baltica, which will connect Lithuania, Latvia, and Estonia to the European rail network. There's also the Brenner-based tunnel that aims to better connect Austria with Italy through the Brenner Pass in the Alps. The idea behind these networks is to close any infrastructure gaps and to ensure better trade and transportation. In 2013, the network's 9 core corridors were announced. And one of these corridors is called the Scandinavian Mediterranean Corridor, also simply called the ScanMed Corridor. It's the longest of the 9 TEN-T core network corridors. Its connectivity stretches from Helsinki to Valletta on these 3 axes. Part of this corridor, the construction of the Fehmarnbelt Tunnel project, is building a faster and better connection between Central Europe and Scandinavia. And this is where the Fehmarnbelt Tunnel makes its grand entrance. The Fehmarn Belt crossing is a 18-kilometer immersed combined road and rail tunnel between Denmark in Germany, or bit more precise, in between the islands of land on the Danish side and Fehmarn on the German side. This is Marcus, just an engineer on this mega project, who was kind enough to tell us all about it. My name is Marcus. I work as construction area manager for Fehmarn, the future owner of the Fehmarn Belt crossing. My main area is the outfitting of the future tunnel elements. And I work on the production facility on our bigger production area for the elements for the tunnel. This tunnel will be used by cars, trains, and trucks once it's completed in 2029. The location of the tunnel will allow for a better connection between Germany and Denmark by removing an existing bottleneck and speeding up travel time. Right now, only car flights operate across the Fehbelt, and it takes somewhere around an hour to complete this journey. When this tunnel is finished, the same journey will only take 7 minutes by train and 10 minutes by car. It'll also boost the link between Scandinavia and Central Europe. And by moving freight from road to rail and using electric trains, this tunnel will be a greener and more sustainable means of railway transportation. But how exactly are they building this insanely long underwater tunnel? It's basically built up in various big parts. So the first big bit was the digging of the tunnel trench. So we're finished with that one. So all the trench is ready for the elements to be immersed. To excavate this underwater trench with such precision, they used big excavation ships that can dig out trenches at deep depths. And it's really done with very high precision that is provided with. We have set up monitoring points or survey points on both sides of the belt. So they can always relate to that one, and then via satellite and GPS and all these measures the operator of the equipment exactly knows where the back hole is exactly in depth, and therefore we can, or our contractor could, provide us a tunnel trench with very high precision. With such a big trench underwater, I wouldn't be surprised if it gets filled up with sediment again after a while. But that's actually not a problem at all. You can think of their method for keeping the trench clean kind of like using a giant vacuum cleaner. We will do a sort of so-called trench cleaning. So, we will clean the trench before we then come with the foundation. So, with the gravel bed, foundation, and finally the element, but there is not much. I mean, there's no tide in this area. The current is manageable. We have very stiff soils. So the tunnel trench is in fact not really filling up that much. It needs to be cleaned. Yes, but it's not big amounts. It's just sort of a bit of housekeeping to be done before we can come in with the foundation and the element. And to build such a huge underwater mega tunnel, a factory had to be constructed where the tunnel elements could be built and transported to their location in the Baltic Sea. This factory is considered the largest tunnel factory in the world. And each tunnel element being built here is 217 m long, about 42 m wide, and 9 m tall. So we have a big factory with 6 production lines for elements. So we produce these immersed tunnel elements on land in big production halls, and these production halls were purpose-built for the Project M, including not only the holes but also big basins which basically function as a lock to bring the elements from land into the water. And we have a very big harbor. The third biggest harbor in Denmark was built just for this project. The harbor and factory is strategically located next to where the tunnel elements need to be immersed. This is not only more practical, but it'll also save a lot of time in moving the elements from the factory to the water. Another big challenge involved is building the tunnel portals, which are basically the entrances to the tunnel. The 2 tunnel portals have already been built. One in Denmark near Rodby Haven and one in Germany near Puttgaren. So the first part of the tunnel is built in situ. In situ means very traditional. You just dig a hole, you place a tunnel and you fill the hole up again. So this we do with the first few hundred meters of the tunnel. In order to do that, obviously we needed a dry area to do that. So you build a temporary dike into the belt, providing you a working area that sticks out into the water. That dry area then excavate. You place the tunnel, the first bit of the tunnel. Once that is done, you place the final dam or the final dike over the tunnel. By removing the outer dike, a piece of the tunnel will be sticking into the water. This part of the tunnel will be the connection point where the first tunnel elements can then be immersed. All in all, the feed belt tunnel will be made up of 89 humongous pre-built tunnel elements, with each section so big and so heavy that they weigh more than 13,000 elephants. But how are these tunnel elements actually being put together? The production of the elements can almost be described as a assembly line production. We start at the very beginning to assemble the reinforcement cage. What he's referring to here is using steel inside the concrete to reinforce it. This reinforcement cage is assembled starting with the base plate, then attaching the walls and then finally adding the top slab. Once that is done, this cage is pushed forward. So obviously the production facility is always at the same spot and the tunnel elements are sort of pushed through the whole production. So once we have this reinforcement cage, it's pushed forward to where we cast this segment. Now we don't cast the whole tunnel element, the whole 270 m in one go. This tunnel element is built up in 9 segments. So we always build one segment at a time. So we build one roughly 25 m long piece at a time. So once I said the reinforcement cage is done, it gets pushed forward with big hydraulic pushers to the area where we cast. The casting itself can be very challenging as it takes more than 30 hours to cast just one segment and the conditions have to be just right. That's also still the first part, at least, is still inside the holes because we have controlled conditions. There is roughly same temperature all the time. There's no wind, there's no rain, there's no snow. So we have this control conditions to get a really good product in the end. It's very challenging casts and the control conditions make it easier to really achieve the product we want and need. Once the casting is finished, the segment goes on to the curing area. Once we have 9 of these 25 m steps, 9 of these segments cast, we have one full element. This full element is then pushed forward outside in the so-called outfitting area, which is also the upper basin of the lock. Once there, it needs to be outfitted. So, there's a lot of things, even though the elements look ready, they're far from being ready, there's a lot of things that need to go in. We need bulkheads at the front and the back in order to make the element watertight so it'll float, it'll swim. And although the factory is close to where these parts need to be immersed, it's still very challenging to transport them to the water. We need to press the segments together in order to be able to transport it. So if you have 9 separate pieces and you would just try to lift that at the bottom at the front at the end, it would just collapse, right? So basically the same as trying to transport 9 books and you're only allowed to touch the first and the last one. You press those books together, then you can lift it, you can place it somewhere else, and once you place it again, you can release it. Okay, but what about the immersion process itself? How exactly do they do it? Well, Marcus explained to us that they use basins built in front of the factory to transport the elements for immersion. Please like and subscribe channel.